400 amps hour. So we want to know the number of panels we can use for this battery bank. So the first thing is to know the energy that is stored in this battery bank. So it will be 24 volts multiplied by 400 amps hour. So this will be 24 multiplied by 400 will give us 9,600 watts hour. So we want to know the number of solar panels. The next step is that we will multiply this by our depth of discharge. So let's assume this is a lithium battery or a flooded battery. So we are going to use 70% DOD. So let's take that is 0.7. So this will be 9,600 watts hour multiplied by 0.7. So 9,600 multiplied 0.7. This will give us 6,720 watt hour. Then the next step is that we'll divide this by the performance ratio of our solar panels. We are using 65%, which is 0.65. So this will be 6,720 watt hour divide 0.65. So this will give us 6,720 divide 0.65. This will give us 10,338 watts hour. So the next thing, we are going to divide this value by the peak sun hours. What is the peak sun shine hours in your location? So let's take 6 hours. Let's assume the peak sun hours is 6. If yours is 3, you put divide by 3. If it is 3.5, you put 3.5. If it is 4 hours, you put 4 hours. If it is 5 hours, you put 5 hours. But for this calculation, we are using 6 hours as our peak sun hours. So this will be 10,338 divided by 6. We will have 1,723 watts. The hour will cancel. This will cancel. So we are left with watts. So this is the size of solar panels we need, 1,723. Now we'll divide this by the power rating of the solar panel we want to use. So you may decide to use 200 watts, 300 watts, or 400 watts. So let's use 320 watts solar panel. So this will be 320 watts. This watts will cancel. So it will now be 1,723 divided by 320 watts. 1,723 divided 320. So this will give us 5.38. So approximately we need 5 pieces of 320 watt solar panels. So these are the number of solar panels we need to charge a 24 volt 400 amps